Hi everyone, this is going to be a short review video on how to simplify square roots of negative numbers and then work with various powers of I. So the first example I'm going to do for you is the square root of negative 169. Now we know that there's no number that we can take when multiplied by itself to get a negative number back, which would satisfy the idea of the square root. So what we learned in class is that the square root of negative 1 is equal to the value of I. And we need to take this into account when we work with these problems. So I can take something like the square root of negative 169 and split it up into the square root of negative 1 times the square root of positive 169. We know that the square root of negative 1 is equal to I. And we learned that the square root of 169, because that number is a perfect square, is equal to 13. So this problem becomes I times 13, but we're going to write our final answer as 13I. And that's how we would go through something that would be a perfect square once we pull the square root of negative 1 out. If I do an example like this, the square root of negative 52, we know, again, we can break this into the square root of negative 1 times the square root of 52. The square root of negative 1, this, is equal to I, but the square root of 52 is not a perfect square. Or 52 is not a perfect square, so we have to think to ourselves, is there a perfect square that divides into 52, that we can break 52 up into factors where one of them is a perfect square? So if I think about it and I think about my perfect squares, I think that 4 goes into 52. I'll try it on the side here. And you can use your calculator to do this, obviously. 4 goes into 5 one time with 1 left over. 4 goes into 12 13 times. So that means I can break the square root of 52 up into the product of 4 times 13. I'm allowed to split up square roots. And this is going to leave me with the square root of 4 is 2. So this will become 2I. And I can't take the square root of 13. I'm going to leave that under the radical. And my answer will become 2I radical 13. These are just two examples of taking the square root of a negative number that might help you as you go through some of your problems. Now, the other type that you're going to see in this first set of problems are going to be simplifying powers of I. And to simplify powers of I, we need to know how often powers of I repeat. That's not going to work. And we learned in class that powers of I repeat every 4 powers. So we need to make sure that we know that this is our situation, that I is equal to the square root of negative 1. I squared is equal to negative 1. I cubed is equal to negative I. And I to the 4th is equal to 1. You need to know this. If you do not know this, this is going to be very, very difficult for you to do. So I might ask you to do an example like this, I to the 82nd. Now, if we know that these repeat every group of 4, every power of 4, I'm going to take the existing power and I'm going to divide it by 4. 4 goes into 8 2 whole times. 4 can't go into 2, so I'm going to put a 0 there. And this is the old-fashioned remainder 2. That means that 2 out of the 4 that I'm dividing by is left over, or 1/2, which if you did this on your calculator would give you 0.5. So if you see a decimal of 0.5, or you do this longhand in a remainder of 2, this is the same as I squared. Now we know that I squared is equal to negative 1. So our final answer, so our final answer, I wrote negative I, is going to be negative 1. I to the 82nd is the exact same as negative 1. Just a note, if you need to remember, on your calculator, this would have a remainder of 0.25, a remainder of 0.5, a remainder of 0.75, and this would have no remainder at all, or decimal, I should say. If you're doing it longhand, this is a remainder of 1, remainder of 2, remainder of 3, and again, no remainder. So that should help you with an example where you have to simplify a power of I. Thanks for listening.